Okay, grade 12, let's look at arrangements of objects in given ways. Okay, here's the first example. In how many ways can 5 different people be seated in the first 5 seats in a school hall? So let's choose some people. Let's call the one A for Alan, B for Bill, C for Colin, D for David, E for Eugene. We'll use boys in this case. Great, and there are 5 seats in a school hall, and we want to find the different ways. In how many different ways can these 5 guys be seated? Okay, now if you think about it clearly, for the first seat, that's the first seat here, any of those 5 guys could have sat here. So they're basically 5 choices. 5 choices. You could choose any of those 5, or any of those 5 could have sat there. So let's make a choice. Let's say Bill decides he's going to occupy the first position. You could have had, instead of Bill, why not have had Alan? Alan could have come down and sat there as well. There's no reason why any specific person shouldn't sit there, but bear in mind, only one person can sit there, but there are 5 people that could have sat there. So there's 5 choices. But let's suppose we'll take C. Okay, and C, Colin sits there, great, or Chris sits there, good. Okay, now, at that stage, how many people are left? There are 4. Now, 4 people, 4 of those guys could occupy the second seat. Any of them could do it. We don't know who, but let's suppose B does. Okay, so Bill there, he comes along and he occupies the second position, which is fine. That means we're left with 3 guys that 3 of them could sit in the third seat. And let's decide that E, Eugene, he sits there. Good. Now, at this stage, we only have 2 people that could sit in the second seat, or the fourth seat, should I rather say. Then we've got D for David, who he would go down, and let's say he sits there, which now means that we have only one person left, and that person is A. And A can go in there and sit there, and he's the only person that would go there. So from the counting principle, in how many ways can 5 different people be seated in the first 5 seats in the school hall? In the first seat, we have 5 people that could have sat there, and 1 did. Then in the second seat, we now have a possible 4 people that could have sat there. Then in the third seat, we have a possible 3, because remember now, of the 5, the other 2 are sitting already. 5 people could have sat in the first seat. 1 sits down. We're now left with 4 people. 1 sits down. Now we're left with 3 people. And then in the fourth seat, we're down to 2 possible people that could sit there. And in the fifth seat, there's only the leftover person who hasn't sat down. He sits down. There's only 1 choice there. And as you can see, that is 5 factorial, which of course is 120 possible seating arrangements there. Okay, so that's quite important. And what we can say is that n people or objects taken in n ways, 5 people sitting in 5 different seats would be n factorial. Okay, now let's look at a second one where it's a little bit different. In how many ways can 5 different people, so we'll take now let's make them girls, Andrea, Belinda, Carrie, Deirdre, and Esme, and these 5 girls want to be seated in the first 3 seats. In how many ways can 5 different people be seated in the first 3 seats in a school hall? Now look at this. How many people or how many girls could have occupied the first seats? Any of those 5. So we could have chosen, let's say we chose Belinda, and she comes there and she sits there. Great. Now, how many girls are left? There's 4. So 4 could occupy the second seat, and we might decide to take Deirdre there, or Debbie there. Let's put her there. Okay, now how many people are left? There's 3 people that could now occupy the third seat, and we might decide to take Esme, and we bring her down. There we go. But now you can see that clearly the other 3 are not going to be involved. They're not going to have seats. But of course they could have actually sat there. But what is important to note, that 5 people in the first 3 seats, 5 of the 5 could have occupied the first seat, 4 of the 5 occupy the second, and 3 of those 5 could occupy the third seat there. So according to the counting principle, we have 5 times 4 times 3 different ways that 5 people can be seated in the first 3 seats. And that, of course, will come to, if you think about it, it comes pretty straightforward to 60 different arrangements, seating arrangements. But there is an important mathematical principle that I want to show you. Another way of doing this, if you look at 5 times 4 times 3, we quite used to having the factorial there. So if we multiply by 2 and then by 1, what we need to do, and this is important, we need to divide by 2 times 1 there, so that they cancel. You've still got there. But what the nice part of this is that this top numerator becomes 5 factorial over 2 factorial, which also means you can see it as 5 girls taken occupying 3 different seats. 5 people occupying 3 different seats. So it's 5 people taken 3 at a time. That's another way you can express it. It's not popular, I wouldn't say. I prefer the 5 times 4 times 3, but that's what some of the books do. Okay, so if we say the number of arrangements of n objects or people taken r at a time is n factorial over n minus r factorial. But don't stress with that. You don't need to know that notation to be able to answer the question. Let me show you, for example, if there are 15 different singers that are hoping to occupy the first 3 places in Essay Idylls, in how many different ways can the first 3 places be occupied? Well, if you think about it, in the first place there are 15 possible winners, okay, of those singers. But once you have selected a winner, 14 people could be in the second place. Now, of course, you've got your second place position, so now 2 people are out of the equation. So it means that for the third position, or in Idylls, there are only 13 possibilities there, and one of those guys of the 13 will win. So you might have here James got first place, so now we're down to 14 people. Bill came second, now we exclude those 2 people and we're down to 13, and Colin came third, and of course the others then didn't feature. But we don't know who won, who came second, who came third. There's 15 possibilities there, because they want to know in how many different ways can the first 3 places be occupied. Okay, so we're not worried about who's winning or second or third. It's how many people could have won, how many people could have come second, how many people could have come third. So from the counting principle, the different possible arrangements would be this, would be 15 times 14 times 13, which is 2,730. Another way you could say, well, there's 15 people, so it's 15 factorial divided by 15 minus the 3 positions that they want to occupy in Idylls. Another way of looking at it as well, which is 15 factorial over 12 factorial, where you subtract the 3 from the 15 there. Okay.